Alright, so what we're going to be looking at now in this chapter is going to be looking at some statistic topics. We're not going to go too in depth, that would be more for a statistics class, but we're going to kind of scratch the surface on a couple different things with statistics. Okay, and the first thing we're going to talk about is probability distribution, and frequency tables and that type of stuff. So there's a lot of different things in statistics. It's a very interesting type of math, and it's got a lot of applications. Anything that has any type of data that you can gather, you can use statistics to prove or disprove any statements. You know, you've got hypothesis tests and everything. But we're not going to go into that detail with this class because we're just going to go over the basics. Okay. So the first thing is frequency. So what frequency is kind of how many times something occurs in a given set. So however many times something occurs over a time frame. You might hear frequency like the wavelengths of stuff. That's how many, wave, periods occur over a certain period of time, or a certain time frame, per second or whatever. That's frequency with sound waves and light waves and everything. But what we're going to be talking about is more just in general data. It's just, there's 7 fours, so the frequency of fours was 7. Okay, that's just how many times it occurs in it. So if we look at this, if we want to find the frequency of the different colors here of each triangle, we see that we have 3 yellow, 3 orange, a blue, and then 3 green. So when we make our frequency table, it would just look like that. We would list the color, and we'd list how often it appears. And at the bottom, you want to do the total. How many total were there? Just because it's going to be nice to have that total when we do the probability of it. Okay, so the probability. So if we look back on this figure here, and if we want to talk about probability, remember probability is the outcome wanted all over total possible. Total possible or total observed. Possible or observed. Depends on if we're doing theoretical or experimental. And so if we have what's the probability of picking a green triangle, well, what we're going to do is we're going to go, okay, how many greens are there? There's 3 greens. Oops. There's 3 greens. And then how many total are there? There's 10. So the probability would be 3 over 10, or 30%, 0.3. Okay. And so how you would see it written would be P, and then in parentheses, what you want for your probability. All right, so for the next one, we want the probability of picking a blue. So what's the probability of picking a blue one? The probability of picking a blue one, there's only one blue, so it would be 1 out of 10. Okay. And so that's what it would be. Now the last one says, what's the probability of picking a blue or a green? So all we have to do is just choose. It could be either a blue or a green. How many blues and greens are there? So total, there is 4 total, so it would be 4 out of 10, which reduces down to 2/5. What you're going to do is you're going to add them together to find these. Okay. All right. And it's kind of called the cumulative probability because you're adding them together. So if you have an or statement, you add the 2 fractions together and see what you get. Okay. Cumulative probability. So that's what this is called right here. Cumulative probability. All right. Probability distribution. So what we can do now is that based on the probability, we can graph these numbers and see how is it spread apart. That's what kind of distribution we're talking about here is how is it spread over all the data. So is one more common than the other? What's the relation between it? And so if you take the frequency of, this is rolling 2 six-sided die. So 2 six-sided die, if you roll them, the 2 of them, you have numbers between 2 through 12. And then the possibilities of each one occurring are here written on the frequency. 1, 2, 3, 4, 5, 6, 5, 4, 3, 2, 1. That's the possibility of having a rolling each of these numbers. So the total probability for each one would be whatever that number is over 36. Okay, because there's 36 possibilities. And to find that, it's basically there's 6 options for each die, and you multiply it by 6 because there's 6 options for the other die. Probability, there's a lot more. When we talk about permutation, combination, and that type of stuff, there's more beyond all that. And so when you graph these, you see we have this nice little kind of curve, how it's even on both sides. And if you look at the data, you can see that it peaks out at 7 and then it drops again. And so that's what's showing here on our data. So by showing the table, it's easier for most people to read it and go, oh, look at, hey, these two, this one and this one are exactly the same. Okay. But this type of curve is called a normal distribution, where it's even on both sides, and we get into that a little bit later. It's also a bell curve. All right. So dealing with probability and different things, there are different traits that people have called either it's a recursive trait or a dominant trait. Brown and blue eyes are a good example of this. Another one, widow's peak, if your earlobes are attached or not. Some are dominant traits and some are recursive. So basically what will happen is that over a long, long period of time, what's going to happen is that everybody's going to have brown eyes because it is the dominant trait and nobody's going to have blue eyes. Now, we don't know when that's going to occur. Again, we don't really know time frame 100% of when that will be. But for now, we still have people with blue eyes and people with brown eyes. And then you've got in between, which green and others. I'm not 100% sure on all that. But basically what it is that everybody has, they get 2 genes, one from their mother and one from their father. Okay. And what happens is that you can use something called a Punnett square. Punnett squared? A Punnett square. And basically what it is that you go, okay, we're going to say brown is capital B and blue is lowercase b. Okay, so the dominant trait is the capital B. So let's say we have a blue-eyed parent. Okay, so what will happen is that this parent will have both their genes will be the recursive, okay, the blue. Because if you have a dominant, you're going to be dominant. The recursive gene or recursive trait kind of falls off, and the dominant one will take effect. And so let's say the next one is brown, somebody with brown eyes, but they have but they carry the recursive gene as well. Okay, and you want to know, okay, what's the probability of them having a blue-eyed child? Okay, so what's the probability of them having a blue-eyed child? What's the probability of them having a brown-eyed child? So what you would do is that you would go, okay, well, it's B and B, B and B, and then it's lowercase, 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 lowercase. So these first 2 would be brown, and the second 2 would be blue. So what's the probability of them having a brown-eyed child? 50%. And what's the probability of them having a blue-eyed child? 50%. Okay. And so you could do this with a lot of different things. If you can identify if they do have a recursive or if they only have the dominant, you're able to make these and then predict and say, okay, there's this chance that it occurs. Now that doesn't mean that if they have 2 children, one will be blue, one will be brown. It just says there's a 50% chance that it does occur. Okay, probability still with the distribution. So if we rolled a dice 200 times, okay, based on our previous table back here, okay, based on this, okay, the first one we wanted to know was 4. So what's the probability of us having roll a 4? How many 4s would come up if we rolled the dice 200 times? And so what we would do is that we would take the probability of a 4 occurring, which was 3 over 36, and we would multiply it by 200, okay, which we end up getting as about 16/6/7 times. So if it all works out perfectly, about 16, 17 times, it would roll a 4. Okay, theoretically. Again, this is theoretical. If it was an 8, we would use the 8, the probability of rolling an 8, which was about 5 over 36. And then 12 would be 1 over 36. And so you go 200 times 1 over 36. And as you see, an 8 would occur about 28 times, and a 12 would occur about 6 times, approximately, of course. And these are, again, what would happen if it was perfect. All right, so again, that doesn't mean it will occur, but that's just a probability that it will happen, or that's the estimated amount. All right, so for your IRAT, we've got Sheldon and Leonard here, and they're going to play rock, paper, scissors. Not rock, paper, scissors, lizard, Spock. They're just playing rock, paper, scissors, just basic. And so we have the games written out here, and we want to make a frequency table for the players in this. So for Sheldon, Leonard, and then if they tie. So what you're going to do is you're going to make a frequency table of how often each one occurs. If you don't know how to play rock, paper, scissors, or don't remember, basically what it is rock beats, or rock crushes scissors, scissors cuts paper, paper covers rock. And so what we have here is whatever the bolded one is, that's the winner of the round. Just so it's easier for you to see, so you don't have to actually figure it out. And so you're going to make a frequency table, and then also find the probability of them winning, of each one winning and it being a tie. So find what the probability is. Okay, so find the percentage. You can put it in a percent or decimal or a fraction. That's up to you. But just also find the probability of each one and make the frequency table.